Using only a kitchen plate, some coated candy, and water, we're going to explore the concept of solubility while doing some fun art on becoming their science hero. Here I'm going to show you one of my favorite quick experiments to do that answers the question, why do Skittles and M&Ms get all over my hands? This can be done in about 5 minutes, but can be expanded for more advanced little scientists. For this experiment, you need 1 saucer for each kid, some coated candy, Skittles and M&Ms work best, but you can experiment with others, and water in an easy to pour cup. You may also have oil or other household liquids to experiment with if their attention span warrants it. So I decided to try this experiment out with 3 different types of candy: Skittles, Chewy Sweet Tarts, and Dots. Next, find a nice level surface to put your plate on and start to arrange the candy around the edge. If the inner part of your plate has a lip, you need to find the best spot that when you pour in the water, it will still reach the candy. Once you have the design you want, you can slowly pour the water in until the candies are partially covered. It is important not to pour in too much water, or the candy will try to float and start to move around, causing the colors to mix. Now the waiting game. You can either choose to eat some of the candy or set up some other designs while you wait. Because this experiment is so quick and is visually pleasing, it lends itself well to doing more than one trial. One of my favorite patterns to do uses 9 candies total, 2 each of 4 colors, and then 1 of a 5th color. You arrange each of the matching colors across from each other, then pour in the water. Once the water has settled, put the last candy in the middle. This design will have a circle in the middle with multicolored curved edges. While setting up a second design, you can start to bring up the relevant scientific concepts. The first is solubility. This is the ability of a liquid to dissolve another substance in it. The dyes on the outside of the candy are attracted to the water more than they are the candy itself, causing them to dissolve in the water. The second important concept is diffusion, which can be observed as the dyes move away from the candy in all directions. While we can observe that the dye will likely go in one direction fastest due to gravity, as no plate is perfectly flat, diffusion is the random motion of molecules, causing them to spread out over time. In fact, if you were to let your experiment sit long enough, all of the dyes would mix together across the plate uniformly. For more advanced little scientists, you can ask them to hypothesize what would occur if we used another liquid, such as oil, instead of water. Remember, oil and water repel each other and do not mix together. When comparing the Skittles in oil and water side by side, it is very clear to observe that the dyes are readily soluble in water, but not in the oil. Oils are typically made of long chains of carbons and will readily dissolve other compounds that are similar to them. However, food dyes are typically organic salts, such as red 40. These salts are made of a large organic molecule with negative charges on it called the anion, and typically single metal atoms that are positively charged called the cations. Water interacts with the anions and cations, separating them in solution and ultimately dissolving the dye. We can still see the color because the organic molecule has a very strong ability to absorb light, allowing our eyes to observe the color in the water. I hope you now feel that you have the tools and information necessary to do this activity with your little scientists. Remember to tune it to their ability and attention span, as having fun should be the #1 goal. If you have any questions or comments, please leave them for me below. And remember to encourage your little scientists to explore and question everything.